Okay, in section 2.5, we're learning about dilations. What do you think of when you see the word dilation? What do you think? Yeah, get your eyes dilated, right? So when we get our eyes dilated, what happens to our pupils? They get larger, right? Okay, so they get larger so the doctors can see deep inside our eye, make sure that our eyes are healthy and that there's no issues with our vision. Okay, so with the dilation, okay, the first thing that we need to be able to do is recognize what's a dilation and what isn't. So we're looking for a center point, or what we call the center of dilation, but really a lot of determining whether a figure is a dilation is in the visual, what it looks like, okay? So it's not rotating, it's not reflecting. It technically is translating because it's sliding. However, the main difference is that it's changing in size, but not in shape, okay? So just because a figure is small and then gets really big, if it changes in the shape of the figure, it is not a dilation. All right, so go ahead and sketch these triangles and you tell me, does it look like a dilation or not? Go ahead and write it down. Yes or no, guys? Yeah, it's a dilation, absolutely. Okay, let's look at the next one. All right, you go ahead and draw the figures, just try to sketch them to the best you can, and you tell me whether or not you think it's a dilation, yes or no. All right, so Caleb says no. Do you agree? Yeah. What is it? It's a reflection. It's a reflection. All right, that's definitely a reflection. All right, let's look at the last one. Okay, go ahead and sketch that one and tell me yes or no. All right, class, what do you think? Yes or no? Yes. Yeah, it is. Okay, it's definitely a dilation. Okay, so just identifying dilations. You have a section like this on your homework. You'll have it on your quiz and your test. All right, now how do dilations work? Okay, you don't have to write this down. It's in your book. But we can tell whether or not it's a dilation by scale factors. Scale factors tell us by what proportion the figure is getting bigger or smaller. What is this word proportion? Proportion. I seem to remember a proportion, like maybe 2/3 and 6/9. How could I tell whether or not this proportion, okay, so a proportion is two ratios that are set equal to each other, but they have to be the exact same ratio. Well, this looks like different numbers to me, so it's not a proportion because they're different numbers. Or is it? Is 2/3 reduced all the way? Is it reduced all the way? Yeah, it's reduced all the way. Is 6/9 reduced all the way? No. What can 6/9 reduce to? 2/3. So 2/3 does equal 2/3. These two ratios are a proportion. This will help you on number 4 on your homework tonight. Okay? But what about, let's say, 2/3 and 15 over 25. Okay, 2/3 and 15 over 25. You go ahead and write the fractions in simplest form and you tell me if they form a proportion. All right, so in order to tell if two ratios form a proportion, they have to be in simplest form. Go ahead and do it on your papers. Ashley should be writing it on your paper. Okay? Even if you think you can do it in your head. Tati, what you think? No. 2/3. What did you get when you reduced 15 over 25? 3/5 does not equal 3/5, so I would say no. They do not form a proportion. So it's important that we understand what a proportion is. Okay, so we have learned those in the past, so we just need to kind of draw on that memory of proportions. In order to be a true scale factor, I have to be increasing each one of the ordered pairs by the same value. in order to keep my proportion intact. Okay, here's what it looks like. All right, I want you to draw this middle set of information right here. Okay, you don't have to write what's in the words up at the top. Write A 1 3, B 2 3, and C 2 1. Okay, so we're going to take each ordered pair, and here's my hint. Scale factor of 3. If my scale factor is larger than 1, then I'm enlarging the figure. Okay, if it's less than 1, then I'm actually reducing the figure. So is this going to be an enlargement or a reduction? Is 3 bigger than 1?
Yes.
Yeah, so I'm actually tripling this figure in size. All right, well, how do I do that? How do I triple a figure in size? I need to multiply each value inside the ordered pairs by 3. All right, so here's what it looks like. 1 times 3 and 3 times 3. Okay, I take my x value and I multiply it by 3, and I take my y value and I multiply it by 3. X and y, and that gives me my new ordered pair. That's the image, and it's dilated with a scale factor of 3. What is it, guys? 3, 9. Okay, so now you go ahead and do B. Go ahead and do B now. Okay, so B, 2 times 3 and 3 times 3, and I get what? 6, 9. Go ahead and finish C.
6 and 3.
6 and 3. And we already established that, yes, it's an enlargement because of the fact that the scale factor is larger than 1. If it's smaller than 1, it's a reduction. Okay, so what does this look like on a graph? Okay, what does it look like on a graph? Well, I just kind of roughly sketched. I kind of ran out of room at the top. Oh, sorry, that's C.
Do we graph this?
No, you're not. I just want you to kind of visualize. If I were to graph this, this is roughly what it would look like on the graph. All right, do you see that it's still proportionate? It's just a larger figure. Okay? All right, so that's a dilation. All right, now let's look at the next example. Now I have just new points, but now check out that scale factor. It has a scale factor of 0.5. It has a scale factor of 0.5. So is this going to be an enlargement or a reduction? It's a reduction, right? And last time I checked, 0.5 is less than 1, right? Right? So if it's half, if I'm taking half of these values now, that's a reduction. Okay? That's a reduction. All right, go ahead and set up your template here. Okay? All your ordered pairs and how we're kind of going to make these conversions. Let's do this. You guys ready?
Yes.
Okay, so let's dilate the figure. W, -4, -6. So I am going to multiply. I'm still multiplying, but now I'm multiplying by a number that's less than 1. So that's going to make my numbers smaller. -4 times 0.5 and -6 times 0.5. You see what I'm doing there? Okay, so guys, what's half of -4? That's all you're doing is halving it. -2. And what's half of -6? -3. Now you do the rest. Okay, so again, in order to keep my dilated figure proportionate, I have to reduce all of my ordered pairs by the same scale factor. How do I know it's a reduction? Because the decimal point's less than 1. Okay, so what'd you get on -4, 8? Okay, who got -2, 4? Raise your hand if you got -2, 4. Yay, guys, you're doing awesome. -2, 4. All right, what about y? 2, 4. What about z?
2, -3.
2, -3. Awesome, guys. Okay, guys, that's like the bulk of what your lesson is about. I want to show you, you have one homework problem like this, number 26. What happens if it's more than one transformation? What happens if I'm dilating and also translating? All right, let's look at the instructions here. It says dilate the trapezoid using a scale factor of 2. Okay, trapezoid is just the type of figure it is. It's not a rectangle. Then translate it 6 units right and 2 units up. Okay, what are the coordinates of the image? So go ahead and set up your points. Are you guys noticing a pattern here with all the examples? We kind of have this setup, this general setup, where we are moving the points according to certain directions. Okay, so -2, -1, what's my scale factor?
2.
2, so I multiply it by 2. Okay, what if my scale factor was 1/4? What would I multiply it by?
0.25.
0.25. What if it was 1/3? What would I multiply it by, roughly?
0.33.
0.33, okay? So remember those scale factors that are fractions, okay? We can always change those to decimals. All right, so what's -2 times 2, guys?
-4.
And then what's the other one going to be? -2. But now it says to translate it 6 units right and 2 units up. So what would I do to x now? What would I do to x now? 6 units right. What am I going to do to x, Tati?
Subtract 6.
Ooh, am I going to subtract 6 if I'm moving to the right? I need to add 6. Sam, what am I going to do to y for 2 units up? Add 2. Add 2.
Yes.
And now I end up at my image of 2, 4. Or I'm sorry, 2, 0. 2, 0. Okay. All right. I want you to do B. Okay, so -1 times 2 is what? -2. And then 1 times 2 is? 2. Okay. Now, what am I going to add to -2? 6. And the reason I add 6 is because I'm going 6 units right. Okay. If it said 3 units to the left, then I would subtract 3. All right. And then 2 plus 2. So what's point B? 4, 4. All right. Have y'all finished C and D? Does anybody need more time on C and D?
I need a little.
Okay, just one more minute. I want to walk around and kind of check your papers, and then we'll go over. All right, so C, 0, 1. All right, so we've got 0 and 1, and then we've got 0 and -1. Okay, and then remember, we're multiplying by 2. So 0 times 2. 2, 2, 2. Honestly, guys, if I was you, I might just like fill in all that and then do the next step, you know? But it really doesn't matter. All right, now we get to the next one. And what's 0 times 2?
2.
0. It's okay. It's all right. I do that too. All right, and then 0 times 2 again is going to be 0. Okay. And 1 times 2 is 2. And -1 times 2 is -2. All right, and now let me add my 6's and my 2's. Plus 6, plus 6, plus 2, and plus 2. All right, and now I get my final ordered pairs. C is going to be what?
6, 4.
6, 4, and D is going to be?
6, 0.
Awesome, guys. Who got those right? Okay, awesome. All right, let's see here. I want to go over a couple things on your homework. Turn in your books to page 74. Page 74 in your homework. I'm hopefully going to make your homework a lot easier. I have made a small change to your homework. Okay, this is on the recording, so if your parents don't believe you, just flip to 14 and a half minutes on the recording, okay? I'm making a small change to your homework. We just didn't have time to get to one of the examples, and that's okay. All right, now look at number 2 on your homework. Okay, you have to describe the sequence of rigid motions. That's going to be a rotation. okay? You're going to have to rotate one of the points and then figure out how it's translating. So that one is going to be a little bit of a challenge. You might need to look back in your notes from 2.4. Number 4, we did one of those in your classwork. Do you remember when we said, how do you know if it's a proportion? What do you do? Put it in a fraction and you do what? Reduce it. If it's the same fraction reduced, then it's a proportion. If it's not, then it's no. Okay, so that's what we're doing on number 3. 3/5 and 15 over 20. Well, can I reduce 15 over 20? Yeah, what can I reduce it to? Something. What can I reduce it to, guys? 3 over 4. Is that the same fraction? Nope. Okay. Look at number 7. You go from A, 812. Where did I get point A, 812 on number 7? And where is point A at? Look at number 7, guys. Where did I get point A from? And the instructions. So that's your starting point for number 6 and number 8. Now you're going to compare it to this point. And how are your X values and your Y values changing if you're going from an 8 to a 2 and a 12 to a 3? What are you doing? So how can you write that as a scale factor? If you're dividing by 4, it's a reduction by how much? If you said scale factor 4, that means getting bigger, but it's not getting bigger, it's getting smaller, so you would write it as a fraction. Your scale factor is 1/4. It's 1/4 because you're dividing by 4. Okay? All right? So if it was half, if the numbers were half, what's your scale factor? 1/2. 0.5 or 1/2. I'll take decimal or a fraction. Okay? Yes, Tati. On 2, that's a great question. Between the red figure is congruent to the blue figure. Congruent, it doesn't say. Well, no, let me see. Number 2, you're going blue to red. According to the answer, you're going blue to red. That's a great question. Okay, so yes, all right, 10, 12, and 14. Okay, we're already through number 14. None of those are graphs. It's just like a yes-no type thing. But now look at number 16. Draw the figure and its image after a dilation with the given scale factor. Okay, that's your K number. On number 16, K equals 0.5. That's your scale factor. Okay? And same with number 18. K equals 3. That's your scale factor. You have to do what we just did, okay, with making our new ordered pairs. So let me go back to that slide. Okay? So you're going to make your new ordered pairs just like we did in our notes, and then you're going to graph it on 16 and 18. Okay? Does everybody understand? There are 2 graphs on your homework. Does everybody understand? Number 26, you do not have to graph it, guys. You do not have to graph 26. All you need to do is give me the new ordered pairs. That's just like example 4. All right? You do not have to do 22 and 24. All right, guys, that's it.